All right, good morning. It's Monday, August the 3rd, and today we're going to take a sort of step back with functions. I want to go over with you guys exactly what a function is before we move any further. So, what makes something a function? All right, so when we talk about this, we first talk about what a relationship is, or a relation that we call it in math. So a relation is simply a set of ordered pairs. Okay, and those ordered pairs could look like anything. All right, they could be a pair of numbers. 1, 2, 3, 1, 4, 1, a set of numbers. Or they could be letters in numbers. They could be anything that is a pairing. Okay, it could be names and zip code. Anything that is set up in an ordered pair of some way is known as a relation. All right. So like I said, any group of numbers is a relation provided the numbers come in pairs. All right. The domain is the first pair, is the first number in the ordered pair, is usually the x-coordinate, and your range is your second number in the ordered pairs, which is the y value. Okay, so here's a table that shows the amount of time it takes for a student to run certain distances. All right, so we've got distances, would be, in this case, would be our domain, our x-coordinates, times would be our y-coordinates, and we could organize this information in a set of ordered pairs. Okay, this is your x, and this is your y. So this is another example of a relation. Now, certain relations are functions if they follow certain rules. Everything's a relation, only some relations are functions. Okay, our domain in this would be anything that is in the x column. If it repeats, we only list it once. So I would say the domain is 10, 200, 300, 400. The range, on the other hand, would be whatever is in the y column. And if anything repeated, we would list it just once. All right, so what makes a relation a function? Okay, so a function is a mathematical relation such that each element in the domain of the function is associated with exactly one element in the range. Now, a way to recognize this is if we wrote them out as ordered pairs, there would be no repeating x-coordinates. The y-coordinates can repeat, the x's can't. And that's what it's meant by everything that is in each element in the domain has exactly one element in the range. So ordered pairs for a relation, to be a function, no two ordered pairs have the same first element. That's the same thing as saying there are no repeating x-coordinates. Okay, so the most important part of a function, every input has only one output. And x cannot have two y coordinates. All right, so we ask ourselves, is this function is this relation a function? Well, if we look at it, if we put these in ordered pairs, you got 1, 2, you got 2, 4, you got 3, 4, and you got 4, 5. Okay, there are no repeating x-coordinates, which means every input has exactly one output. So this would be yes, this relation is a function. Okay, now if we look at the second one, all right, and ask ourselves the same question, is this relation a function? Well, you can see right now that there's a repeating x-coordinate. So each one of these, this input right here, 1 has two outputs, and that can't happen. 1 can't be paired with 5 and at the same time be paired with 7. Okay, that would mean this is not a function, it's just a relation, because the 1 violates the rule that it's got too many outputs. It can only have 1. Now, when we talk about pairing these things up, we often refer to them as a mapping. So if I took all the elements that were in the domain and I drew arrows to the elements that they match up in the range, then that'll help me tell if it's a function or not. All right, so if you look at this, I just paired up how they're associated with each other. Okay, and the question is, well, would this be a function? So if you looked at it, 1 matches up with 5, 2 matches up with 6, 3 pairs with 8, and 4 pairs with 8. Okay, none of the x coordinates repeat. So this would be a function. This particular kind of function is known as a one-to-one. Each element is associated with exactly 1 y coordinate. Now, the reason that makes it one-to-one is not only do none of the x coordinates repeat, but none of the y coordinates repeat either. So that's one thing that makes a one-to-one function. Okay, to be a function, the x's can't repeat. To be a one-to-one function, neither the x nor the y repeat. So one way to think about functions that kind of helps you decide if something is a function or not is if you think about, like, you're playing either basketball or football, and you're covering each other. You're out in your backyard playing football, or in the gym playing basketball. So you got one team, let's say they're team X, that's the domain. Okay, and then you got team Y over here, that's the range. Okay, so if we were playing basketball, let's say, we're going to just play man-to-man defense, then player 1 would be guarding player 5, player 2 would be guarding player 6, player 3, 8, and player 4, 7 on the other team. So this is an example of a function. Each person is covering one other person. That's known as a one-to-one mapping. So this is a one-to-one function. Okay. There are no repeating x's. So if I wrote out these in terms of ordered pairs, none of the x coordinates repeat, and none of the y coordinates repeat as well. So no repeating x's, no repeating y's makes it one-to-one. Inputs, or the x's, do not repeat. Outputs do not repeat. That is a one-to-one. Alrighty. Now, like I said, you can have y coordinates that repeat. That's okay. So in this case, let's say we were playing basketball again, but it was 4-on-3. All right, and number 7 for the other team's a really good player. All right, so now we've got 1 is going to cover 5, okay, 2 is going to cover 6, and 3 is going to cover 7, and 8 is going to cover 7. So this makes it a function because none of the x coordinates repeat, all right, but the y coordinates repeat. That's okay. We call this a many-to-one function. Okay, all this means is that the outputs have a repeating value, or you have a repeating y value. So outputs can repeat, inputs cannot repeat. So we would call this a many-to-one function. Now, the reason we got to learn about one-to-one and many-to-one is because only one of these will have an inverse. And that's what we'll talk about some more when we get back to inverses. All right, now we've got the teams have switched. Now, the 3 players are on X and the 4 players are on Y. Okay, so if we were playing, 1 would have to cover 5, 2 would cover 6. So far so good. But player 3 has to cover 7 and player 3 has to cover 8. This would not be a function, okay, because an input cannot have 2 outputs, or an X cannot be mapped onto 2 Y values. And you can see here that this X coordinate is being mapped onto 2 Y values, and therefore this would just be a relation. It's not even a function. So the easy way to remember, guys, is functions, the X coordinates won't repeat, and that makes it a function. Okay, if the Y coordinates repeat, that's okay. That just means it's a many-to-one function as opposed to a one-to-one function. If one of the X values repeat, though, all right, so if we looked at this relation, we want to know, is it a function? Well, it's pretty simple. We just look at the X coordinates. No repeating X coordinates. This thing would be a function. All right, all this is like a little function machine here. Okay, we've got these would be our inputs, goes into the machine, and that's its output. So if we were to draw this using like a machine type analogy, 3 gets paired with 1, 5 is covering 2, and 4 is covering 3. Everything in the domain is different. There's no repeating domain values, therefore this thing is a function. Right? Determine whether the relation is a function. Well, look at the X values right away, or the inputs. That tells you you got a 5 being paired up with a 2, and a 5 is being paired up with a 3. We know that this is a relation. This is not a function. And right there, player 5 has got to cover player 2, and player 5's got to cover player 3. That's not good. And therefore, that is not a function. All right? So, is this relation a function? Well, all you got to do is look at the X's. They don't repeat. Okay, so this is a function. This is a particular function. Is it a one-to-one or a many-to-one? Okay, let's go back to that. So if I was to draw the mapping for this, okay, my domain is 1, 2, okay, my range is just one element. So that's just a 3. So this is okay. You got repeating Y values. That's fine. That would be a many-to-one. So it's 3 people. It's 3 versus 1 in a basketball game. That's fine. It can't be 1 versus 3. Okay, if it was written the other way around, whereas it was 1 player here, and that player had to cover 3 people here, that would not be a function. That is a relation. All right, would this satisfy the requirements for something to be a function? Your domain are math students in the class, and the correspondence is their birthday. So the range is going to be made up of a set of dates. Question is, would this be a function? And the answer is yes, because a person, or excuse me, let's go back to that. A student can't have more than 1 birthday. So every student would have exactly 1 birthday, and that would make it a function. Now, if we switch the two, okay, if we made the domain a set of dates, correspondence being their birthdays, and the range be a set of students in a class, would this be a function? And the answer is no. Okay, 1 date could have more than 1 birthday associated with it. Okay, so we could have August 3rd, And there could be 3 people in that classroom that have August 3rd as their birthday, and in that order, that would not be a function, that would simply be a relation. All right, now you're all familiar with the vertical line test. We use that to see if something is a function. And the reason it works is if it fails the vertical line test, that means that you have repeating x values. Okay, so for example, this would fail the vertical line test. If I drew a vertical line, okay, it touches that more than once. So this has an x coordinate, these 2 points have an x coordinate of 5. So 5 has this y coordinate, and 5 also has this y coordinate, and therefore that would not be a function. That is a relation. Sort of think about it, we use a pencil to represent the vertical line. That fails the vertical line test. All right, so if you picture taking a pencil and moving it along that line, or that graph, would it ever touch the graph more than once? And the answer is no. Okay, so this would be a function. Okay, so we could see, if you think about taking a pencil, moving along sideways, this x coordinate right here, which is 1, 2, 3, -4, would have 3 different y coordinates associated with it. That's definitely not a function. Okay, so if you picture a pencil moving along this, okay, as it slid along from left to right, it would only touch once. That is a function. You could see this would not be a function. If I put the pencil right there, let's say at x equals -2, that x coordinate would have 3 different y coordinates with it. A 1, about 2.5, 1, and then 5, 6. So -1 would have 3 different y coordinates. That is not a function. Pretty easy to see. Only touches once. Now, a graph doesn't have to be connected in order to know if it's a function or not. Okay, so this is known as a discrete graph. That means the points are not connected with a line. Well, you do the same thing. You're going to ask yourself, could I take a pencil and slide it along here, and if it ever touches more than 1 point, then it's not going to be a function. Okay, and you can see right there, that pencil touches those 2 points at the same time. Therefore, the x value of 3 would have a y coordinate of a 1 and would also have a y coordinate of -4. So that x coordinate is covering 2 people. That is not a function. Okay, now here's one that always kind of gets people. This is known as a step function. Now, if on these steps here, when you look at the steps, if the circle is full, okay, that means it's part of the graph. If the circle is open, it's not part of the graph. Okay, so again, if you took a pencil now and moved it along this graph, it never touches the graph twice, because in the places that it does appear to touch the graph twice, one of the circles is not open, like right here. Okay, so it does that right there, it doesn't touch the graph because that circle's open. This would be a function. Okay, now if you look at the next one here, this is not a function because at this x value of 1 or of 6, it has a y value of 0, and this point is also on the graph, and it has a y value of 1. So 6 would have a 0 as a y value, and 6 would have a 1 as a y value, and 6 can't cover 2 people. So that's a no-go. This is a relation, not a function. Now, if we did this one and asked ourselves, is it a function? No way, because right here at -1, it has an infinite number of y values, because that's a solid line. So definitely not a function. This is a relation. All right. To determine whether or not these equations are functions or not, we're going to use Desmos. So in Desmos, you're simply going to type in that equation and then determine if it passes the vertical line test. All right, so if I do that, we can see that this easily passes the vertical line test. Therefore, it is a function. Okay, now we got a rational function. Well, it is a function because I just called it a rational function, but we have a relationship here. And when I put this into Desmos and take a look at it, it's the red graph. And if I take this vertical line and I slide it left and right, it only touches that graph once, even in this little space right here. Okay, that's about 0.66 it'll turn out. And that vertical line doesn't ever touch the red line, okay, because it's an asymptote. So even though it looks like it might, it does not. So this relationship is indeed a... All right, now the equation says x equals y squared, and we want to determine, does this relation define y as a function of x? That means, does it pass the vertical line? So if we take a look at this graph, you can see right now that it definitely doesn't pass the vertical line test. So that relation, y is not a function of, all right? And the next one is x squared plus y squared equals 4. Is this a relation that defines y as a function of x? So if we go back to Desmos, that equation in, and you can type it in just the way that you see it, squared, and we get a circle. And a circle is not a function. So y is not a function of x for that last example. All right, so that takes care of just some more basics on functions. You're going to have a Math Excel assignment on this. It'll be Math Excel 1. And it's called What is a Function? And that'll be due on Wednesday. So we'll see you next time.